My name is Daniel Diltz. I am a firmware engineer at GE. I have had a bit of a sore throat the last few days, so if it gets too bad, this may devolve to vague hand waving. When I first floated this topic on a mailing list, just seeing if this was something that might be interesting, one of the responses came back, well, this is a really easy topic. This is one slide. Don't use global variables. Nice in theory, it's like everything else. There's often a lot of reasons not to use sections of the language. Global variables, global variables tend to get a bad rap. They do tend to, use of global variables does tend to lead to data sharing and to making it difficult to reason about what's actually happening and who's causing pain. So I'm going to start out with a little bit of some advanced code. Pretty sure everybody's seen this. Pulled this out of my copy of Kernighan and Ritchie. This is the absolute basic code everybody learns when they're trying to learn the language. In C, it's pretty basic. You've got your call to display to the screen, and lo and behold, it outputs what you would expect. C++, you can always use the C libraries, but there are new ways to do it. More object-oriented. They may be, in some cases, more performant or easier to understand, less error-prone. So you might rewrite it this way using IO strings. You have your string, you're outputting it to your stream, and lo and behold, it goes to the console. So what does this have to do with global variables? Well, with C, with printf, not a whole lot. There's not really any use of globals. But when you go to C++, there actually is. You have cout, and when you rewrite it, you're actually calling a global operator with cout, which is a global variable as a parameter. Okay, so even in something this trivial, in C++, you will sometimes run into global variables. So they, unfortunately, can be rather pervasive, and particularly with older code and with newer code. So yeah, you've got a global. In order to talk about global variables, you really need to know, what are we talking about? What is a global? In this standard, there's 4 types of storage duration. There's static storage duration, there's thread storage duration, automatic, and dynamic. Of these 4, really only going to talk about static and some about thread. Static storage duration is kind of the bucket. If it doesn't fit into one of the other categories, it gets this storage duration. This really is mostly what you think of when you think of global variables. This is anything at global scope, namespace scope, or just variables declared outside of functions or classes. Also, static class members also fit into this category. Sorry, a little nervous. Thread storage duration. This was added, I believe, in C++ 11. These variables are specific to one thread. That one thread, each thread will have its own instance, and when it's used within a thread, it only gets its threaded version. Okay, sorry. Automatic storage duration. These are your typical variables. These are the ones that are in your function bodies and your method bodies. It's pretty easy to reason about their duration, when they start, when they stop, when the constructor gets called, when the destructor gets called, and yeah. And the last is dynamic storage. This is when you use malloc or new to allocate memory on the heap. It is, you are responsible for making sure that the memory is released, that it's destructed, as opposed to automatic storage duration, where the runtime makes sure it happens, and it happens at the right time, hopefully, if you coded it right. With global variables, there really are some serious problems. You do get unintentional sharing. Often you're like, well, this variable is only going to be used here, and I need to have a couple of methods that need to be able to share the state. So I'm just going to use one variable, and the next thing you know, somebody else comes along and says, oh, great, this variable has exactly what I need. I'm going to use it, and it gets away from you very quickly. You do have reasoning about lifetime and controlling lifetime. There's not a whole lot you can do about controlling the lifetime. It starts at the beginning, it ends sometime after main, and you don't have the fine-grained control that you do with automatic or dynamic storage duration. Generally not thread safe. It is global variables, not the thread local ones, but the global variables are shared across all threads. Any thread accesses them. It can change it out from under somebody else. It can, do horrible bad things to each other, race conditions. I mean, your typical stuff. It has a tendency to make code execution confusing. You are sharing data across large portions of your code, and you may not be aware of who's using the data, who's writing the data. You may have originally, but these things tend to get used. And then, when global variables do get initialized, it tends to, there often can be dependencies, and it's not always easy to reason about the dependencies or to guarantee that the dependencies are satisfied. Yes? Okay. Yes, the statement was, I was about to. The statement was made that in C++11 we also add one more pain point with globals. It is possible somebody could decide to move out of your global, and then now who knows what's left. I could probably, in most cases, I think, lead to very bad behavior. Okay, yes? So the question is, so for dynamic memory, it has to be allocated somehow, through an allocator, through malloc, through new, through some other mechanism I can't think of, and it has to have its free store somewhere, somehow, and so isn't that a kind of a global variable? Yeah, I guess you can look at that as a global variable, but if you are replacing the free store out from under malloc, you've got real problems. That's mostly managed by the runtime, and hopefully the runtime knows how to manage it. Yes?
You mentioned that there are different kinds of allocators. You have general purpose allocators like the lead allocator, which is synchronized. But you also have allocators that live in only a single thread. They're not synchronized, and they take their memory off the stack sometimes. And those are particularly fast because, number one, they're taking their memory from the stack, and two, they don't have to do anything with locks or anything like that.
Yeah. Okay. The comment was made with there are different types of allocators. You do have your general purpose allocators, new and malloc and those type, and those are often, they're synchronized, they're well behaved. But you do have others. You can have special purpose allocators that may allocate memory on the stack and therefore be thread local, and so it's not really an issue with this. Absolutely agree. Okay, I'm just going to work through just an example of some of a little use of global variables. Project I was working on, I wanted to do something very similar to automatic registration of unit tests. We see this in different things. G-test, boost test. I mean, there's lots of different things they do it. It's pretty well defined, but the problem is getting through it. You actually hit most of your pain points you get with global variables. So, you start out with main. You got to start out somewhere. And the first thing I do is I added a container for my tests. You could do it without a container and just inline call everything. But initially I'm just like, well, I'm going to do it that way because I know I'm going to need it eventually. Added my test, created my test. It's going to do something, whatever I decide I want to test, however I'm going to do it. And, I register it by putting it in my container. I can, this is very easy to repeat. I can add more functions wherever I want. I can just add more lines of, put it into my vector. Once it is in your vector, you do have to have some way of running it. Just use the for each loop and just call every test. It's pretty straightforward, pretty easy to do. But well, this is nice. But every time you add a test, you have to go in and remember to add it to your list, and hope that everybody else who's added a test has added it to the list. And if you decide to remove a test, you got to remember to remove it from the list, or you're going to get a compile error, and it's just more bookkeeping. And there should be some way to avoid having to manually keep track of if it's added, should it be added, where to add it. So since we want to be able to register the test, we have to move our test cases collection out to global scope. At this point, if we're going to do automatic test registration, it's not done in main. It's done before main starts. And so it can't be in the scope of main. Ideally, what we'd like to do is just be able to call pushback at global scope, but that's just not legal. I tried it in my compiler just to check. I figured it wasn't. So that's just, you can't do that. So there has to be some way to execute code before main. And it turns out, unless I miss something, the only way to do this is with global variables. This is, it ends up not being a global variable to share data. You can use it to share data. I mean, I wouldn't recommend it, but you can. And so what I ended up doing was, we create a structure which will be used to register our tests. What the structure does is we now have a constructor, which is a point where we can run code before main starts. We also added a destructor. We can run code after main ends, but in this particular point, I'm more concerned with running code before main starts so that the registration can take place. And I have to create an instance of my struct so that when that gets, when everything gets initialized, see, when the runtime gets initialized, the constructor will be called, and then the constructor can register. Okay. So here I've added the constructor. I have the constructor calls pushback on the vector and pushes the test back. This works great for this case. When globals are initialized, order of initialization in one translation unit is top to bottom. And so, test cases will be initialized first. Register test will happen. So that will happen after the constructor for test cases, and everything works, and it goes through, it runs, everybody's happy. Yes?
Now, if you put your tests in another translation unit, it doesn't work?
I'm going to get there. Short answer, the question was, if you put your tests in another translation unit, will this work? I am going to get to that. The shorter answer is maybe, if you're lucky. And if you're not lucky, bad things happen. Did a little bit of rearranging, moved the helper, the register helper up, and instead of hard coding the function that it's calling, I made it a constructor parameter, and now I can just create my global instance and pass my pass my function in, so that I don't have to have a separate class to register each test, which would be painful and lots of code and frankly unnecessary. Excuse me. My first pass through, I did do that, and yeah, it was painful. I just to make it so that I could go through and actually, use a macro to clean this up to make it friendly and kind and nice and less boilerplate code. I just moved the helper up, forward declare my test function, and now we're in a state where you can actually replace this section with a macro. So instead of declaring your test, registering it, and then actually implementing your test, you can just go through and replace it with a single macro. And I'm glad this code's legible. So now I have a macro, create test. You see this in most of your unit test frameworks. The macro, I want to add a unit test. I just write create test. What's the name of the test? I write my test out, and it will get registered. I can do as many as I want. It's, not a lot of code noise, and it just works. Boost.test. I wanted to go through and just double check, how does an actual unit test framework do this? How did they do it? And and this was the solution I came up with. And so boost test, this is what you'll do. You define your test module, you include your header, and then you register your test case like this. Pretty straightforward, looks very similar to the solution I came up with. Ran it through a preprocessor, reformatted the code to be a little nicer, and lo and behold, they have their static object, their global object, that registers the test. Theirs is quite a bit more complex than mine, and probably, hopefully, with that much more complexity, does more than mine. But they have their helper to do the registration. They pass in the parameters, including the test, and it registers it, and the test gets called eventually. So, okay, so the next thing I wanted to do, pull some of this out into a header file. No point in having everything in one file. Makes it a lot less flexible. So I moved the helper class and the macro out to a header file. This header file is, with a few changes that will be shown, is just assumed to be included in everything else, that all the other code. And on the right, okay, did I do something wrong here? Okay, no, sorry. On the right, I actually have the body for the constructor. I have my unit test. I still have main, and I have the container for my test cases. I made the container static. It's only needed in this translation unit. The reason it's only needed in this translation unit, so I really don't want anybody else to be able to see it. And so, if you have to have a global variable, try to make it static so that it doesn't get too far away from you as easily. It's still pretty easy to get away from you. So, the next thing I want to do, I have my main, I have my runner. That's nice. That should come with the library, assuming it's this way. So, I move my test out to another translation unit. I create my test. Everybody's happy, life's good, except it's not. At this point, life sucks. The issue comes down to the order of initialization and destruction of globals. It's pretty well defined. I spent many, many hours going over the 2 or 3 sections that were relevant. Basically, if you have your class, it prints out on, constructor, destructor. You create them in main, you get exactly what you expect. The constructor gets called, constructors get called as they go down, and then everything gets destructed on the way back up. It's very easy to reason about. It's very easy to look at and see, okay, this is going to work. And darn it, I wish globals were that easy to reason about. They're not. Now, when you get to dynamic storage duration, you have the new, you have the delete. The constructors get called at new, they get called at delete, rather than top to bottom, bottom to top. And so, rather than having A, B, C, CBA, A gets deleted first, B gets deleted second, and then C automatically at the when main returns. So dynamic and automatic storage duration are pretty easy to reason about. They work how you expect, and yeah. Now, when you get to globals, in one translation unit, it's not too bad. Globals are constructed before main. The runtime goes through and constructs them. Then main gets executed, and so C and D get constructed, and then everything runs in the reverse order, which is nice. Again, you see A, B, C, D, D and C, which are in main, get destructed at the return of main, and then after main, eventually the destructors for B and A get called. Everybody's happy. You return to the operating system and hope that everything else went well. For global variables, the initialization is not as simple as it is for automatic and dynamic variables. Automatic and dynamic, it allocates memory for automatic. It allocates memory on the stack, calls a constructor on it, and you're good to go. For dynamic, it allocates it it allocates it in some method, heap or otherwise, it eventually gets constructed, and and you can go with. Yes. This one? Yes. No. There's a pattern involved with this, but yeah. Okay. Okay. The question was, is there a possibility C out will be deconstructed before your destructors are run? The answer is actually no, though it looks like it should. There's some funky stuff with C out, and I will be getting into exactly why. But the answer is no, fortunately. Otherwise, it would be even more painful. Okay, so for when you initialize global variables, the memory is allocated by the runtime. It's not allocated by main. It's not allocated by any function or by any function that you have. It is allocated by the runtime, and so in most cases, there's often a section in your executable file that is your globals. Global initialization of globals has 3 phases. The first 2 are static initialization, and the third is dynamic initialization. So all variables with static storage duration, the first part of static initialization, are initialized to 0. All padding bytes are initialized to 0. All data bytes are initialized to 0. And then after 0 initialization, you have the rest of static initialization, which is the constant expressions, integer constant expressions, const expr, and other things like that are written, whatever the value of those is written over the 0 that's been initialized. I mean, if it's in a section in your executable, that's all just going to be in your executable and be mapped at once. That's all generally done at compile time, so that they can just put it in the executable. Everybody's happy. And then the last part is dynamic initialization. You have dynamic initialization is when your constructors are run. You have both ordered and unordered initialization. Ordered initialization is when you explicitly specialize a class template, and when you any global variable that is explicitly declared at scope. Those are the order of initialization, and how they're initialized is very well defined. Excuse me. And then the other sub part of dynamic initialization is unordered initialization. Unordered initialization only covers your template members that are not that are for templates that are not explicitly specialized. The compiler doesn't generate them unless it needs it. Who knows which translation unit it's in? They may be initialized, they may not be. They may not exist. Who knows? Hopefully you don't need them to exist, and they don't exist. But if you do need them, it should generate them anyway. So just a quick example of how this goes. You start up, it's got the addresses that your variables are allocated at, and whatever garbage is in memory. So before any initialization is done, you've just got whatever garbage is in memory. And so the first thing that is done is we do zero initialization. All the memory blocks are initialized to 0. Okay, that's easy to reason about, at least. I like 0. Better than garbage. And this is different from automatic storage duration variables. Automatic storage duration variables, if you don't initialize the memory, it's whatever is left over from the last time it was used. Maybe something good, maybe something bad, maybe security leak, anything. For globals, though, it's always 0 initialized. Even the padding is 0 initialized, and yes, it does say that. After that, you have to do constant initialization. In this case, of the 3 variables I have, the only one that is constant initialized is the third variable. I'm just passing in a character literal. The other 2, they're not const expr, they're not some type of constant expression, and so they are not at all touched by constant initialization. And then, yes? Well, you always have the as if rule, right? So it's as if. You can't do anything between 0 initialization and constant initialization. That's just part of the runtime. So the normal way it happens is you have sections in your executable. I forget exactly the names. One of them will be I think BSS is your section that has just your 0 initialized stuff. Okay. No point to keep it in the executable, so it's usually an empty section and just says 0 out this range of memory. And so that's the way it usually keeps track of the 0 initialized stuff that is not constant, doesn't have constant initialization. And then there will be another section where your constant initialized globals will be. That one I really do not know. And so, as if. Yes?
I have a different model of this, and I just trying to understand. Both the 0 initialized variables and the ones that are initialized with a constant, I would expect they would be part of the executable and have nothing to do with the runtime. And I think that the 2 phases that you're talking about have to do with runtime initialization. So what happens is it's first 0 initialized, and then the runtime runs and overwrites the 0 initialized space. But I can see no reason at all why the constant section in the executable would not already be set with the constant, and it's already set when you load the program.
Okay, so let me see if I get this right. Correct me if I'm paraphrasing you wrong. You would think that this initialization is like separate from the runtime mostly. That the runtime will go through, it'll have the 0 initialized section, and then it will just map over that for the stuff that's already constant initial.
I want to say that those things that are initialized with constants, or for example, the address of, suppose I have a variable that takes the address of another object. If those things happen, if they're compiled on constants, those constants will exist in the executable, and when the program is loaded, there will never be a point at which it was 0 initialized.
Correct.
However, if it's runtime initialized, there will be a point where it was 0,
Mm-hmm.
and then it will get initialized.
Right. So what he's saying is, for those that are constant initialized like this, it's basically just going to store those values in the executable, and it's going to map them into memory. However it decides to do it, that's implementation dependent. And so there will never be a point where it actually was zeroed for that section. That's correct. There's a special section, I don't remember the name, where these globals that are constant initialized, their memory is allocated, they're allocated there, and then whatever the initial values are is just put there, that's mapped into memory, and your program begins executing. This is the conceptual model for how it works. How it's actually implemented is usually that you do have special sections, so that you don't have to do that computation at runtime. Yes. Yeah. Okay. Yeah. He said with embedded systems, it is the BSS section. It's initialized at loader time. It's not in the executable itself. The one I have at work, I do embedded systems also. There is a BSS section, which is just empty. It's zero space in the executable, and it just is. This is the section that is going to be zero initialized. We tend to write direct everything out to flash, and so that's memory mapped. So it actually does write zeros out to memory, but it's a special case. For Linux and Windows, this tends to be how it's done. And then okay. Any other questions? Okay. The last part is dynamic initialization. I used rand just because I could. I don't care what the value is. I don't care that it's a good random number. It was just so that the compiler didn't play tricks with me. So dynamic initialization goes through, and this generally has to happen at runtime. And it goes through and actually runs the constructors. So in this case, short doesn't have a constructor. It's zero initialized. It doesn't have a constructor. So dynamic initialization doesn't touch it. Third's already been statically initialized. It doesn't need to be initialized. So the only thing here is first. First has a constructor. Constructor just assigns a random number to its two members. I've got a short, I've got an int. So the short gets whatever that value is. The padding gets left as 0, hopefully. And then the integer gets assigned another random value. The reason I used rand instead of just putting some value in there is the compiler is permitted, if it can prove that there are no side effects, it's permitted to treat the constructor, the dynamic constructors as static. It doesn't have to, but if it can prove there are no side effects, it's allowed to, which then would have completely screwed up my example, so I had to use rand or something else that was not, it couldn't determine at compile time. Nice, it's all nice and dandy. It's top to bottom. It happens. Static initialization, zero initialization generally happen at compile time. It'll, create its section and everybody's happy. Dynamic initialization is top to bottom. Whatever order your globals are declared in your translation unit, that's the order dynamic initialization happens. It's easy to reason about that. The problem is when you get to more than one translation unit. It is unspecified which order the translation units are initialized in. And so you could have, you have two translation units. It could initialize your first one and then your second one, or your second and then your first, or if it really wanted to be fancy, I think it's permitted to interleave the two translation units, which, yeah. This causes a lot of pain if you're dealing with multiple translation units like you do with a unit test framework. I don't know of anyone who wants to write all of their code in one translation unit. And if you do, no, please don't. The other thing that gets painful is as soon as a thread is started, if you start a thread, it's no longer unspecified, it's completely unordered, which means that now, instead of just being able to interleave, it can run multiple constructors for your dynamic initialization at the same time, which makes it even more difficult to reason about what's going on. So generally, please don't start threads before main, because it will make initialization of globals much harder to reason about, and is going to break somebody's global that they didn't realize was going to be run in parallel with something else. It will cause threading issues. So in this case, I just put struct inline. It'd normally be in a header somewhere, but I didn't want to try and hide another file. I've got 2 translation units. I have the left-hand side is one translation unit. The right-hand side is the other translation unit. For me, this is probably the scariest code I've ever written, and not because it's just a stupid example. When I wrote this, I'm like, okay, this is a really easy one. I can reason about this. This isn't too bad. Because you've got 2 orderings, assuming it doesn't interleave. It can initialize E and then F and then A, B, C, D, or it can do A, B, E, F, C, D. But the constructors are using IOStream. The constructors are outputting to the console, and so cout has to be initialized. Including IOStream, we know at the point, it's guaranteed that by the time you get to initialization, everything that's in IOStream, cout is valid, it's in a good state, you're good to go. So if it initializes the second translation unit first, cout's going to be initialized, we're going to call the constructor for A, it's going to output, we're going to be happy, B constructor outputs, gets happy, we're happy, comes over to this one, well, we know cout's been initialized, so E and F constructors are good, everybody's happy. The problem is if you go the other direction. If this translation unit is initialized first, what happens? What happens then is the constructor for E gets called. Well, that's in this other translation unit, which hasn't had initialization happen yet. The second translation unit, we've got our constructor, which uses cout. Cout has not been initialized because we've not hit IOStream in our order of initialization for globals. So we're now using an uninitialized cout in the constructor in this translation unit because the compiler or the linker decided to order it in that order. Now there's a third order it's allowed to do initialization in. It's allowed to postpone initialization until after main starts for dynamic initialization. When I first ran into that, it caused me many headaches. The nearest conclusion that we could come to after much discussion on Stack Overflow was likely this is in the standard to permit dynamic linking, dynamic libraries. But it's allowed to postpone until after main begins. If it does that, it has to initialize all of the variables in a translation unit before anything in the translation unit is ODR used. Which means if it decides to do that, it's going to call main. Before it gets to initializing C, it has to initialize all the globals in that translation unit. So cout is initialized, A is A constructor, B constructor, C constructor, D constructor, but it never initializes anything in this translation unit. Yes?
So that means if I altered the program at main, it actually has not even constructed A or B.
The question is, if he halted the program at main, it has not even constructed A or B. It's permitted to have that behavior. I don't know of any compiler that actually does that. Okay? Just because it's permitted doesn't mean anybody does it. But I assume it's to give implementers leeway to do something efficient on their platform and to cause me pain. So if it does that, if it goes through, these will never get initialized. But the other way is, there's the possibility that it could use these and use an uninitialized cout. Not a good thing. I lost sleep for several days trying to reason about this and how to fix this, because you don't want to have extra header files in your own header file. It increases compilation dependencies, increases compilation time, just not a good thing. And the only conclusion I can come to is, if you're using a global variable in your constructor, you have to include the header file for that global variable in your header file. Otherwise, you can't guarantee that initialization of global variables, assuming your variable is created as a global, will happen in the correct order, or that any dependencies will be initialized before you get to your constructor. That's the only conclusion I could come to. I don't particularly like it. Yes? Yes. Question is, rather than using cout directly, couldn't you wrap it in a Myers singleton and then use it through the singleton? Yes, you can do that. Wait, let me think. Let me think.
The lifetime of that variable is not necessarily the longest
Right.
lifetime. And I do want to point out, cout, Sierra, CLog are all special cases.
Yes.
And compiler vendors do not use the nifty counter.
Right.
They just cheat.
Yes. The statement was made that cout, Sierra, CLog, the IO stream is not initialized, at least in most cases, in this manner. They're actually initialized as a special case by the runtime. This is true. I ran this through Microsoft, went through a lot of assembly, and yes, they do not do that. But
The nifty counter thing has the flaw that you demonstrated, because if you don't get the includes, in other words, if you
Yep.
insulate the client, which is a good thing to do, the nifty counter breaks.
right. And so his statement was, if you're trying to insulate the client by keeping your header, your includes as close as far down in CPP files as possible, that it will break. He's calling it the nifty counter, and the pattern that's used to guarantee ordering, and that is true. This tends to be a bit brittle. If it's going to be used as a global and your dependency is on a global, you have to have that header file in your own header file, or you can't guarantee initialization. You just can't.
What if you have mutual dependencies between your objects?
I'm going to get there. Question was, what if you have mutual dependencies between your objects? I am going to cover this. Actually, on the next slide. Okay. In automatic and dynamic duration variables, you can't have circular dependencies in your constructors, because it already has to be declared and initialized before you can reference it. And so it has to be linear. May be a nasty variant on linear, but it cannot be cyclic. When you get to globals, it's quite possible to have a cyclic dependency, where so in this case, I have two global variables, A and B. They're pretty simple. They've got a constructor, they've got a get to return an integer. I really don't care what the integer is, it's more the example, so I'm not doing anything for pre-initialization. The constructor for A calls b.get. It's dependent on B having been initialized. So B, the value returned by b.get says, let's get a.get. And so you've got a cyclic dependency here. What happens? This is undefined behavior. Likely, it has been 0 initialized. So likely you're just going to get 0 for both, but who knows? It's undefined behavior. It's allowed to do whatever it wants.
Reference something before its runtime thing has happened, aren't you going to get the 0 initialized
Likely, but it is.
Okay, what if you have a recursive initialization of something where it's static and it comes in and it calls itself? You see what I'm saying? Suppose I had something like,
Whoa, so if you have a okay, so what happens if you have a global variable that recursively calls itself to initialize itself?
suppose you have some sort of static function that where, even in function scope or whatever, I mean, the point is that there has to be a first time that you,
Yes.
and that one has the 0. And then you can imagine,
Yeah.
as you recurse back, getting more value
Right.
as this thing executes.
Okay.
This is crazy nasty stuff.
Yes. No. This is, if I remember right, this is all undefined behavior. Don't do it. Avoid the cycles. Sometimes somebody will introduce another global, and they will introduce a cycle they weren't aware of. Okay. You need to be aware of this if you're going to use globals. Avoid cycles. Very rarely will it actually do what you want, and it can often break things very, very badly.
I just want to say, even if you don't have the cycle, if you don't know the relative order of things,
Yep.
you'll get flaky behavior.
Yep.
And when I was working at the company before I work now, the most common reason for core dumps was somebody created a static object
Mm-hmm.
dependent on some other
Yep.
static object. That was like the number one reason.
Okay. He said that, even if you don't have the cycles, you still have your relative ordering issue between translation units that causes flaky behavior. He said the number one cause of core dumps at a previous employer was actually this exact issue. Yeah, it causes bad problems. It is undefined behavior. It's allowed to do whatever it wants. It may do what you want it to do, and likely it will not. Okay, this one, I just got rid of the cycle. And so one ordering is well-defined, the other one is undefined behavior because we're calling, if B gets initialized first, A has not been initialized, you probably will get the 0 from it, but it's not guaranteed. If A gets initialized first, you're fine because it doesn't have any dependencies. B gets initialized, it calls A.get, gets the 5, everybody's happy. So relative ordering, even if you don't have cycles, can cause you much pain.
So I have a lighter question.
Yes.
Suppose if you were saying that calling something that isn't initialized is undefined,
Mm-hmm.
and if the order isn't specified,
Yep.
then isn't the unspecified behavior now undefined? See what I'm saying?
The unspecified behavior leads to undefined behavior, but it is not itself undefined.
I understand that point, but in this particular instance of the unspecified, but in totality, it's undefined. Because there's some, could be,
There is some case where the unspecified turns into undefined, and therefore you might be able to claim that the unspecified behavior is actually undefined behavior.
programmers are saying that.
If I see somebody at work writing this code, I am going to be discussing in detail global initialization with them, or maybe just point them to the recording of this talk. Hopefully that's easier. So there's really two ways of dealing with this. First is a singleton. I do like using the Myers singleton for this. The other is a Schwartz counter. Pull out your Spaceballs reference as you decide. Schwartz counter is named after the gentleman who developed it for the IOStreams library to deal with this exact problem. Myers singleton, it's pretty simple. We have a static inside of the function. Because it is a static in the function, it is guaranteed to be initialized the first time that execution hits the declaration. Yes? You're correct. For this one, I do want to return a reference, but I'm not. This is a bug in my code. You're absolutely correct. You would probably want to return a reference. This is nice. In C++ 11, this is guaranteed to be thread safe. You're guaranteed that cases will only be initialized once, There's generally an implementation detail as a lock so that it only gets into it once. And so that's really nice and really convenient. There is one issue with this. If you have multiple Myers-Singletons that reference each other and you get a cycle, that is undefined behavior also. I ran it on, what?
Well, I was just going to give you one more thing. Suppose I have an object that I create before I get involved in the Myers-Singleton.
Yep.
Right, where the constructor calls the Myers-Singleton.
Yes.
So you said to watch that.
Yeah, he said, suppose you have a global or,
I have a global object,
okay,
and let's call it John, and in its destructor,
yep,
because it doesn't do anything but annoy you,
sure,
in its destructor it calls the Myers-Singleton.
Okay.
I have another object called Lakos that in its constructor calls the Myers-Singleton.
okay.
Okay, in that case, the annoying one will blow up.
Okay, he's saying if you have one global, the constructor calls the singleton,
The first one, the call is in the destructor.
oh,
The second one, the call is in the constructor.
okay,
You will wind up calling the Myers-Singleton after it's been destroyed.
okay. He is saying if your first object, this Myers-Singleton is called in the destructor, and your second object, the Myers-Singleton is called in the constructor, you're at some point going to use the singleton after it's been destroyed, and then you're pretty much hosed.
And if you think this doesn't happen, there was a person in my company that no longer works there who created a single object with nothing in it except the destructor. And so the entire training system ran after main was done. Not kidding.
He's saying there was a gentleman where he works or used to work that wrote a class with just a destructor, and that basically took down the entire system running after main.
Right. The entire training system ran after main.
Yeah, that's not a good idea. So there are gotchas with this. It is easier, mostly, to reason about the initialization of this because it does happen when it first gets called. Doesn't matter what translation unit it's called from. The other pattern is a Schwartz counter. The gentleman who developed it was Jerry Schwartz. He was working on the IOStream library and was trying to figure out how to deal with this exact problem. So basically what it does is it constrains the initialization of a single variable between translation units. You could write a Schwartz counter to constrain multiple variables, but for our case, we're only going to use it to constrain one. This is the basic pattern. We have two translation units and a header file. In the header file, we have a class that is our Schwartz counter. In this case, we're going to use the Schwartz counter to keep track of and make sure our variable A is initialized. Okay? We create a static instance in the header file. This means that every translation unit that uses our type is going to create an instance of the Schwartz counter. And then we have our declaration, our forward declarations for everything. So in the translation unit where we define the Schwartz counter, we have a global int, and you can do it without the global, but this is the way I'm doing it. In this case, static, so nobody else uses it but our translation unit. And then the constructor, when the constructor goes in, we increment, we check for 0 so that we only initialize it once. If we started out at 0, we do a placement new on A, and that's all the constructor does. A has a constructor, just sets it to 5, we're fine. And then B, or the second translation unit, it includes our header file, so it creates a Schwartz counter. Schwartz counter guarantees that A has been initialized. B uses a.get and sets I. So in this case, it doesn't matter which translation unit gets sequenced first. It can initialize the first or the second one, and the Schwartz counter will guarantee that A is initialized before B is initialized. There are gotchas to this. A will be initialized twice. Okay? The Schwartz counter initializes A in place. And then the runtime is going to go through when it initializes the first translation unit, and it's also going to initialize A. A will be initialized twice. In this case, it doesn't matter. I don't really have any state, but you know, if your Schwartz counter is protecting a vector of function pointers, you're going to leak memory. You may only get part of your tests in your run. I mean, it's potentially a very bad problem. So I am going to go back to the example. Yes? This one? Did I do postfix? Let's see. I did postfix increment. So it returns. Yes, you're correct. I want equals 0, not equals 0. Yes? Assuming you have not gone through and started a thread on your own, it doesn't matter. It will be single-threaded initialization. So I don't have to worry about thread safety unless somebody goes through and decides to start a thread, and I really don't want to deal with that, so I'm going to pretend that doesn't happen. What? Oh, could use interlock operations. I really don't want to do that. Yes, you can do this with atomics. There are ways to make this thread safe. I am going to bury my head in the sand and assume that nobody starts a thread before main. Okay, back to our unit tests. So we have this issue where we have our tests are in one translation unit. Our tests, our container that we're registering our tests into is in another translation unit, and we could potentially try and register our tests before the container has been initialized, which is not a good idea. Please don't try and push back to a vector that has not had its constructor called. It's probably going to crash. So I'm going to do two implementations, one with the Myers singleton and one with the Schwartz counter. In this case, Myers singleton, we have our function test cases that returns a reference to the vector. I got the reference this time. And when we register the test, our constructor for our test registration class calls the function and then pushes back. And then main is, instead of just for each in the vector, for each in the vector returned by the singleton. For this case, this is probably your better solution. This is probably, it's cleaner and it's easier to reason about than the Schwartz counter. So for in this trivial case, this is probably the better solution. It's not the only solution, and there will probably be cases where the Schwartz counter is the better solution. So I'm going to do both of them. Schwartz counter. We have to rewrite our header file because we have to add a Schwartz counter. Added the class. We have our static instance of the Schwartz counter. Every translation unit is going to get an instance of the Schwartz counter. And then the rest of it is the same as it was before. Now we get to the bodies. The translation unit where we're declaring our tests, nothing changes. That's nice. I can change my library out from underneath you, and you won't know as long as you recompile everything. You don't have to touch your code. We go to the translation unit that has the test runner and everything. We now have to have our int to count for the Schwartz counter. It is, remember, it is initialized to 0, so this is not me playing around with an uninitialized variable. I know it's 0, so I'm not going to assign 0, though I could if I wanted. And we have our Schwartz counter. And I may have the negation on this again. I have to look at this in more detail to know for sure. Oh, it is correct this time? All right. I got it right once out of two. Schwartz counter will make sure that the test cases vector has been initialized and we get down to main, and it'll call it, run everything in test cases. This is great, except the ordering between translation units. The test cases is going to be initialized twice. So, if this translation unit gets initialized first, the Schwartz counter will get run. We will construct test cases, and then we'll register our 2 test cases. Great, they're registered, everybody's happy. Wait, we go to this other one, Schwartz counter does nothing because it's already initialized, and then the runtime initializes test cases again, so we just leaked the memory that this translation unit allocated, and we no longer have references to our test cases. That's probably not the behavior we want. And then main will happily execute all 0 test cases that we now have, even though we registered 2. So, got to figure out a way to solve this. There is a solution. I hope the one I came up with is the right solution. Oh, and just to be a good citizen, I'm adding a destructor to the Schwartz counter so that we can make sure that our vector gets destructed. In this case, we don't want to do double destruction either, but I'm going to take care of that. So for Schwartz counter, we have our placement new of vector. Right now, the destructor does nothing. What I did to take care of this double initialization is, instead of having test cases be the vector, I'm having test cases be a reference to a vector. Reference is only dealt with in static initialization, so it won't be double initialized. And then I used align storage, and this particular, the default template parameter for the second template parameter is whatever the most constrained alignment is, which is fine. It also makes my line shorter. So we have storage that's the right size and at least as strictly aligned as what vector takes, and we have our reference pointing to that. The align storage will be statically initialized, but it will not be dynamically initialized. This means that our vector will not be initialized by the runtime. Because we're using a Schwartz counter, this is okay. We're now down to a single initialization of the variable that our Schwartz counter is protecting, rather than having it initialized twice. That's a good thing. The rest of the code is the same. Okay. And then, so, and this one, I'm just adding the destructor. So we're decrementing, and when we get to 0, we have to explicitly call the destructor. The destructor will not be called by the runtime, and so we have to explicitly call it. And I had to look up the syntax for that. I've never actually called for a template explicitly. So we've guaranteed at this point that the constructor will be called exactly once, and the destructor will be called exactly once, rather than twice or 0 or some other number that will cause us pain. So that really is, that's the only way I could come up with to make it so that the variable protected by the Schwartz counter was not double initialized. There may be another way. If somebody comes up with another way, please let me know. This one.
This is actually to use in minor singleton to achieve the absolute, if you want the be-all and end-all, the absolute best solution. I don't know if can you go back to the minor singleton?
Yes, I can.
Okay. So the same idea, but what you want to do is, let's say you have something that has a node upper bound for space.
Okay.
If you're talking about something that's unbounded,
Mhm.
this won't work.
Right.
If you got something where you know it's no bigger than, it's not going to be bigger than this, even if it uses dynamic memory, you can do that trick of creating the static that on first call, newing it into the static buffer and doing the same reference thing we did. But the problem is that would leak memory unless the memory that you allocate dynamically is taken from static storage using an allocator. In that case, what you've done is you've built a permanent object.
Mhm.
So the first time it's used, it's there and it stays there till the end of the program because the destructor never gets called.
Right.
And unless there's some other resource that has to be dealt with besides memory, this is the best solution I've been able to find.
Okay, so your solution involves having the buffer,
Yes.
the global buffer, like I had, and then using a Myers singleton to do the initialization of the global of the buffer, rather than having the Schwartz counter go through and do its magic that way.
Right, but the important thing is if you're okay with leaking memory, which we shouldn't be because that
Yeah.
just gets in the way of their diagnostics, then you don't even need to do the last thing.
Right.
If your object that you're creating allocates memory, which
Okay.
ours would, you would provide it with an allocator that takes its memory from another buffer.
Ah, okay. So what you're saying is if your object you're allocating allocates memory itself, you give it an allocator, and then that allocates from that global buffer that you've allocated, that you've used with the line storage or whatever, and then you use that for initialization, and so you aren't leaking memory because you have a single buffer that you know is going to be deallocated at the end of main, and so you aren't leaking the memory, even though your vector or whatever it is has leaked memory because you don't have it anymore, even though,
Show up anywhere.
but it doesn't show up anywhere as being leaked memory. Okay, that's a interesting way of dealing with it.
I've had this problem for like 25 years.
25 years. We've been having problems with global variables for 25 years? Okay. Where am I at? Okay, so that's the wrong one. Okay, basically, the solution I come to, global constructors can be problematic. Destructors also. With constructors, you can have circular dependencies. Circular dependency is undefined behavior. Or if they get initialized and the translation units are initialized in orders separate from what you think they're going to be, you get undefined behavior. You've got to be very careful, or it's very easy to get undefined behavior with global variables. Avoid circular constructor dependencies. Something I hadn't thought of earlier apparently is avoid destructors that depend on other globals, because those other globals may be destructed already and may crash your program. Also, if you do have dependencies, make sure they're ordered. Use a singleton, use a Schwartz counter, or some other pattern to ensure that the ordering happens in the way you need it to happen, rather than hoping and praying your linker lays things out right so that the ordering happens in the way you need it to happen. And don't use globals for data sharing, please. It's bad enough to see a local variable get leaked somewhere farther up the stack, but at least that has the minimum scope, you know. But global variable for data sharing, you don't know who's got your variable, you don't know who's changing your data, you don't know who's reading your data. Just generally don't do it. I guess that's really what I got. Anybody have any other questions? One more question.
If you could go back about 3 or 4 slides, the one where we did the registration, where you were registering in one translation unit and the global variable was in the other. Is that this one? Yeah, I think this will work. Suppose I get very smart and I send to put all of my test code in a library. So each .o is in a library.
Sure.
And I link my main with this library.
Yep.
What do you think happens?
Is it a static library or a dynamic library? Are you dynamically loading the library?
I'm going to say static for now. But when I say static, it's an archive. It's got a bunch of
Yeah, you've got a bunch of .os. I'm only familiar really with the way Windows does it. That's all I really work with. The way Windows deals with static initialization for dynamic initializers is it generates a special function for each global object. Okay, so each .o is going to have a special section, and it's like $CRT dot something, I don't remember, and it will put a pointer to that generated function to each one. The generated function calls the constructor and then calls @exit with the destructor. And so you have that section in all of your .o files. When the linker gets it, it combines all of those into one section, and then the C runtime goes through, gets the beginning and end addresses, and just runs through all of them. So if it links it statically, that's going to happen at the first time go through, and you're fine. If it links it dynamically, if you link dynamically and you're loading later, those constructors, those globals will not be initialized until you go through and actually load the DLL.
So just for example, is there anything in main that calls any of these things in the separate?
No.
So in Unix, you'll wind up with an empty registry because all of those things, the only reason they would get pulled in is they're resolving an undefined system.
Right.
So that's one of the sad things about global variables
Yes.
trying to use as registration.
Yes.
Because it behaves differently depending on how it's packaged.
Right. So the issue is that global variables behave differently depending on how they're packaged. This is true. This causes problems. Yesterday, actually, I was going through some of the code for Clang Modernize, and looking to see what is involved in adding another piece of functionality to it, and they're using something very similar to this to register each of the passes. The thing that really threw me off was the very last line in the translation unit is a volatile global variable initialized to 0. I assume that that is to deal with this exact problem, because otherwise the linker can go through, says, translation unit of main. I can't find any dependencies on this other .o, so I'm just going to discard it. I'm not even going to look at it.
You said volatile?
Volatile global
Yeah.
initialized to 0. I assume it's something with the...
I don't understand why the linker would give any attention to that.
I don't know. I just know what I saw in the code. And so my assumption is it is to prevent the linker from just completely discarding a translation unit. I don't know.
Smart enough to know that. The linker's,
I don't know. I just know what I saw in the code. Yes.
So can you go back to the beginning where you were describing the
Thread storage.
you were describing the different types of storage.
Okay. Yes. Let's see. Wow, that was back a ways.
That was, yeah.
Okay, thread storage.
So, how is it, so it's clear with the thread local?
Yes.
So, it's interesting, this is all new. So the thread local, you put that in front, like static, is that what it's like?
Yes, I believe so. I do not have any compilers that actually support this feature at work or at home. So I believe it's similar to just declaring it static. Okay. Somebody in... He says yes. Yes, I believe it's the exact same. And then, other than that, it's they pretty much behave the same way as global variables. Each thread gets their copy. When the thread is spun up, the runtime initializes all the thread locals for that thread. When the thread ends, the runtime destructs them all, and the thread's done. So they behave pretty much exactly like globals, except the duration is for the duration of a thread rather than the entire duration of your program. Another question.
Well, this is a comment.
Another comment.
And I don't know where this fits in, but I can tell you that there is a way with templates and static
Mm-hmm.
that in fact you can declare them in a header and have them pulled into multiple translation units, and static initialization of all of those works fine.
Okay.
It's a magic trick.
Okay.
And
Let me repeat that far so I don't forget that. Basically, he's saying that there is some magic that can be performed with templates and static that will make sure that the initialization just happens fine. Okay.
And essentially, well, I mean, I can show you with an example of it in Boost. And, you know, essentially, you have a template of something, and then you have a static, say, inside that class. Externally later, you can specifically initialize that. And again, it just works. And I don't know which storage class that fits into.
So you have a static member of a template. That fits into static. But so it's not an explicitly specialized template. It's just a,
Yeah, I think it actually is special.
okay, because boy. Okay, because the problem is if it's not, if it is an explicitly specialized template class, then the statics are going to be initialized at the same time as all other statics. They have the exact same behavior. If it is not explicitly initialized, your only guarantee is it will happen before you use it.
That's specialized.
Specialized.
It isn't specialized.
Thank you. Thank you.
So this is not specialized. The initialization is separated from the declaration. Yeah, so you're saying
It's,
just magically, but normally when you, if you did this normally with a static variable in a header file,
yep.
okay, you would get a multiple declaration problem. But because it's a template, in fact, does not suffer that issue.
You have a schema with viewpoints, and you have the static one time in the definition.
Right, but your linker is going to see it in multiple translation units.
Static, you said,
It is static, but there can only be one definition of the static variable. Now you've got at least two translation units with the definition for the static variable. Therefore, your linker is going to see two definitions and go, I can't deal with this, fix it. You can't?
So what the case
Oh, you're right. You're right, a static variable. We're particularly talking about a static member of a template,
okay.
which is a different case. Sorry. Yes, we're,
Yeah, that's a different.
that's a very different beast.
Templates are dealt with, and each individual thing is placed in the Dotto in its own section, or effectively. So.
Yeah.
So when you get one, once you get one, you're resolved, and you never try to get one again. And pulling one of those in does not pull in the whole Dotto, which is different from the way other things are handled.
Okay.
You know, like for example, the fully specialized template, it acts just like it's not a template.
Right.
But the one that isn't, then
Yeah. Okay. Yeah. So the fully specialized template acts like it's not a template. Static members are initialized just like any other statics, but for the non-fully specialized template, that one behaves differently. You're saying that it basically creates its own section for each variable or something.
The translation unit is going to take each instantiation of a particular template thing
Mhm.
and put it in its own section within the .o, so that whenever a .o is used to resolve this thing, it pulls in just that, no other, nothing
Okay.
else. And then, from then on, the linker isn't hungry for it anymore, so it won't try to get it from anywhere.
Okay. So what?
I think the link time optimization gets to that.
He's saying he thinks the link time optimization damps this behavior out. I don't know. I don't know a whole lot about optimization, and I know even less about link time optimization. Okay.
So, you know, just to finish it, if you want to find out where it is, I can show you it's in the datetime library.
Okay.
It initializes arrays of strings
Okay.
that are used, and again, if you include this header from multiple translation units, so multiple .os that you then link together, you still only get one copy. Sorry about that.
Okay. Yeah, I would be interested in looking at that. Okay. Anything else? Are we done? Okay? Appreciate you guys coming to listen to me.